All right, ladies and gentlemen, welcome. Today we are going to talk about arc length. So give me 1 second while I get myself acclimated and start sharing my screen. Um, so, arc length is not something new. We have seen it before. In fact, it has been discussed in your geometry courses. So, let me just define the arc length according to your textbook, and we're just going to see three very quick examples on how you would use the formula. So, if we go to your textbook defines arc length or the arc of a circle or by saying that it is proportional to its central angle. For example, we know that for special cases, when the arc length is equal to the circumference of the circle, the angle measured in radians corresponding to one full rotation is 2 pi. So now we're going to assume that we're given the central angle and we want to find the arc length. So arc length is given to us in by the formula where S equals R, which is the radius, multiplied by theta, where theta is in radians. So give me 1 second again. uh, the formula where S equals radians multiplied by theta, where theta is given to us in radians, and S equals the radius times the angle times pi over 180, and in this case, theta is given to us in degrees. So let's actually go ahead and look at the first example. And the first example that we're going to see is finding arc length when the angle is in radians. So we're going to use this formula. Okay, so in the first example, we're going to use this formula. We're going to find arc length when the angle is given to us in radians. So the example says, in a circle with a radius of 10 centimeters, so in example number 1, we are being given the radius of the circle, which is 10 centimeters. So give me 1 second. So we know that R in this case is 10 centimeters. And very important that we always map out the information that the problem is giving us. So that way it is easier for us to work and find the solution quicker. So we know that the radius is 10 centimeters. It says in a circle with a radius of 10 centimeters, an arc is intercepted by a central angle with a measure of 7 pi 4 radians. Find the arc length. So theta is 7 pi over 4. And we're being asked to find the arc length. And we know that the arc length is given to us, or is represented in this case, by the letter S. So all we need to do is just find the answer. So they're not asking us to round to the nearest tenth. The problem is not saying round to the nearest tenth or anything like that. So they're not asking us for an exact answer, which means we can leave our answer expressed, in this case, in radians. So we're just going to plug in the formula. So we know that when theta is in radians, we say S equals R times theta, where theta is given to us in radians. In this case, the radius, not radians, I'm sorry, the radius in this case is 10 centimeters. And theta is actually 7 pi over 4. So we're just going to multiply 10 times 7 pi over 4. And we're going to leave the answer expressed because, again, the problem is not asking us to give you the answer in any particular way. It's not asking us to give the answer in to the nearest tenth or anything like of that sort. So we simply leave our answer expressed. So 10 times 7 is 70. and that would be 70 pi over 4. However, we can reduce the fraction. So 70 pi over 4, 70, 0 is technically an even number or divisible by 2. So basically, I reduce that fraction by dividing everything by 2. And my final answer is that the arc length, or S, is going to equal to 35 pi over 2. Again, we divide by 2. So 70 divided by 2 is 35. So 35, and 4 divided by 2 is 2. So obviously our final answer in that case would be 35 pi over 2 centimeters. Had the answer been asking us to give the exact value or rounded to the nearest tenth, had it been indicating one of those things, then in that case, then we would just use a calculator to find our answer. And then in the next example number 2, we are going to use this formula again. Let me read the problem to you guys. Example number 2 says, in a circle with a radius of 7.5 centimeters, an arc is intercepted by a central angle with 76 degrees. Find the arc. Approximate the arc length to the nearest centimeter. So again, we have, in this case, we have our answer given to us. So we have the radius, but the radius in this case is 7.5 centimeters. And we're getting the value of theta, but we're getting the value of theta in degrees. So theta is actually 76 degrees. And the problem is asking us to approximate the answer to the nearest centimeter. So we know that this is the approximate sign. So approximate to the nearest centimeter. Nearest centimeter. So we're being given theta in degrees. So because we're being given data in degrees, that means that we have to use the second formula to find the arc length. Okay, so we're looking for S, which is the arc length, but approximated to the nearest centimeter. Now, we're going to use the formula, but we are going to say, well, S equals radius, which is 7.5 times theta, which is 76. So let me write the formula, times theta multiplied by pi over 180. Pi over 180 degrees. So even though we're rounding our answer to the nearest centimeter, we are using the radians measure as well. So we just plug in our numbers and we say 7.5. So the radius is 7.5. Theta is 76 degrees. And pi over 180. So we use a calculator for this, and we approximate our answer to the nearest centimeter. So what we can do is we multiply 76 times pi over 80. And then, so in our calculator, and this is of course is S, and what we're going to do is we're going to multiply using a calculator 76 times pi over 180 times 7.5. So this would be S equals 7.5 centimeters times 76 pi over 180. And what we do is we find a way to divide this. So we divide it. So we can just go ahead and, plug those numbers into the calculator. But another thing that we can do is we can simplify the fraction with 76 pi over 180, and then it'd be easier to work with. So 76, we can divide it by 2, and that would be 38. Or we can, and we can say 76, so we can divide 76 by 4, or by 2, but I used 4, and that would be 19 pi, and so 76 divided by 4 is 19, and pi over 45. And I believe that we cannot simplify that anymore. So now what we do is we multiply 7.5 times 19 times pi over 45. So what we can do is we can say 76 times 19, or we can say 19 times pi in our calculators, divided by 45, and multiply that number by 7.5, and that would give us 9.948. So we'll say S equals approximately 9.948 centimeters. Eight centimeters. But since we're rounding to the nearest tenth, we simply say that our final answer is that S is approximately. We're rounding to the nearest tenth, and if I look at the number here, 9, or to the nearest centimeter, excuse me, if I look next to the 9, I have another 9, so that means that this number is closer to 10. So that means that we would say that 9 is approximately 10 centimeters. Approximately 10 centimeters. And that would be our answer for example number 2. So we're going to do one last example. story problem as well. And then that would be the end of this video lesson. So that would be the third example of the section. And what we're going to do, that's what I'm going to do, is I'm actually going to erase this. And you know what? I'm going to actually keep the example number 2 because it's very similar. We are going to be using the same formula. Give me 1 second here. And let me actually go ahead and erase all this. And we'll be doing our last example of the video lesson. So today's video lesson is not very complicated. It's more of a observing or plugging in the numbers into the formula, seeing how we have a bit of circular movement and how we use the arc length to determine that. And this is used for various things. Amongst those is, of course, engineering, which brings us to the third example on page 100, and I believe this is 127 of your textbooks. It says, the International Space Station is in approximate circular orbit 400 kilometers above the surface of the Earth. If the ground station tracks the space station when it is within a 45 degrees central angle of this orbit above the center of the Earth. In this orbit above the center of the Earth, above the tracking antenna, how many kilometers does the International Space Station cover while it is being tracked by the ground station? Assume that the radius of Earth is 6,400 kilometers. Round to the nearest kilometer. So it's saying to round to the nearest kilometer. So once again, we are going to use the formula that says the S, or arc length, equals radius multiplied by the by theta given to us in degrees multiplied by pi over 180. So the numbers that we have 6,400, which is assuming that is the Earth's 6,400 kilometers, which is assumed to be the radius of the Earth, 6,400 kilometers, but the space station tracks the Earth is 400 meters or kilometers above the surface of the Earth. So we actually have to add the 6,400 kilometers that is assumed to be the Earth's radius to the 400 kilometers of the space station, because it's 400 kilometers above the Earth's surface, which of course equals 6,800 kilometers. So 6,800 kilometers is the actual radius, and it's saying that they track it once it is at a central angle of 45 degrees. So now that we have that, we can simply plug in the numbers into the formula. So we know that S is going to equal to the radius, which is actually 6,800. Again, the 6,400 that is being assumed is the Earth's radius plus the 400 kilometers of the space station. So 6,800 times 45, because they say that 45 degrees, because they say that it's measured when it's at a central angle of 45 degrees. 45, that does not look like a 45. 45 degrees times pi over 180. And then we have to round that to the nearest kilometer. So what I would do is first multiply 45 times pi over 180 and have that angle, give the measurement given to us in radians. So this would be 45 pi over 180. 45 pi over 180. And we bring down the 6,800. $800. And we multiply S. So we can reduce this, and that would be 6,800. And of course, we know that 45 and 180, I can just divide by 45. So that would actually be 6,800 times pi over 4. And then we look for our calculator and we multiply 6,800 times pi and divide that answer by 4. And then we're going to round because it says approximate or round to the nearest kilometer. So 6,800 times pi divided by 4. So 6,800 times pi divided by 4 equals approximately 5,340.708. So give me one sec. Let's move this toolbar here, taskbar here real quick, so I can have the space that I need. Okay, so then we say that S is 5,340, 5,340.708. And then since they're asking us to round to the nearest kilometer, what I'm going to look is next to the 0, I have a 7. So that means I round up. So S is going to be approximately 5,341 kilometers. And that would be the end of this video lesson. So we saw 3 examples of how to use arc length. First, if the theta is given to us in radians, and then if theta is given to us in degrees. So hopefully this video is helpful to you guys. Stay safe, and we will see each other soon. Bye.